So, okay, so remember last time we learned about the cross product of vectors in space. So remember the definition of cross product is in terms of this determinant I hat, j hat, k hat, and then the components of A, A1, A2, A3, and then the components of B. And this is not an actual determinant because these are not numbers, but it's a symbolic notation to remember what the actual formula is. And the actual formula is obtained by expanding the determinant. So we have actually this smaller determinant, A2, A3, B2, B3 times I hat minus determinant of A1, A3, B1, B3 times j hat plus determinant of A1, A2, B1, B2 times k hat. And we also saw a more geometric definition of a cross product. So we've learned that the length of the cross product is equal to the area of the parallelogram with sides A and B. We've also learned that the direction of the cross product is given by taking the direction that's perpendicular to A and B. So in fact, if I draw A and B in a plane, they determine a plane together, then the cross product should go in the direction that's perpendicular to that plane. Now, there's two different possible directions that are perpendicular to a plane, and to decide which one it is, we use the right-hand rule. Which says if you extend your right hand in the direction of vector A, then curve your fingers in the direction of B, then your thumb will go in the direction of the cross product. Okay? So one thing I didn't quite get to say last time is that there are some funny manipulation rules. What are we allowed to do or not do with cross products? So let me tell you right away the most surprising one, maybe if you've never seen it before. It's that A cross B and B cross A are not the same thing. Okay. Why are they not the same thing? Well, one way to see it is to think geometrically. Sure, the parallelogram still has the same area, and it's still in the same plane, so it's still perpendicular to the same plane. But what happens is if you try to apply the right-hand rule but exchanging the rules of A and B, then you will either injure yourself or you will end up pointing in the opposite direction. Okay? So in fact, B cross A and A cross B are opposite of each other. And you can check that on the formula because see, for example, the I component is A2B3 minus A3B2. If you swap the roles of A and B, you will also have to change the signs. Okay, so that's a slightly surprising thing, but you'll see one easily adjusts to it. It just means resist the temptation to write, AB equals BA. Whenever you do that, put a minus sign. Now, in particular, well, what happens if I do A cross A? Well, I will get 0. And there's many ways to see that. One is to use the formula. Also, you can say just that the parallelogram formed by A and A is completely flat, and it has area 0. So that's the 0 vector. Okay.